Well, that's a perfect segue to our last speaker of the morning, because Aloise is the Director of Laboratories and the Co-Director of Graduate Studies in the Department of Chemistry and Chemical Biology at Harvard, bridges both roles. On the one hand, he's done two things. One, he has overseen and had new space, tens of thousands of space that's been built for laboratories that's safe, efficient, and sustainable. And then secondly, he has an academic role. He actually, in co-directing the graduate studies program, oversees about 200 grad students. So he has experience in both realms that he can speak to, I think, and be our last speaker. He also has a PhD in chemistry from Harvard University. Welcome, Alan.
Good morning, and thank you for the opportunity to visit with you today. I've had the pleasure of being associated with laboratories at Harvard in several different capacities. I've worked in them as a researcher. I've taught in them as an instructor. I've managed the safety programs of them as a safety officer. As an administrator, I've participated in the decommissioning and demolition of laboratories, and I've also overseen the design and build of laboratories. And in my career, I've seen that we've come a long way through the work of some of the very people in this room in turning spaces that look like this, with inefficient, constant volume fume hoods, students arrayed next to open chemicals on the bench, asbestos-coated everything, inefficient lighting. So labs that look like this into labs that look like this in a very efficient and manner and in a way that's mindful of human health. We can take underutilized space in a basement that looks like this and transform it into a modern laser spectroscopy lab, again, in a way that's mindful of the environment and human health. From a mechanical perspective, we can take dozens of always-on exhaust motors that exist in a 1-to-1 ratio with every fume hood we have in that building and turn them into something that looks like this, an array of precisely controlled exhaust systems that are driven by variable frequency drive motors and very efficient supply air that we have fine control over. So these are all projects that have been completed in the last 18 months in the chemistry department. One reason for our success in these projects is that we have very specific quantitative energy, health, and financial metrics that we can share with our leaders to demonstrate the wisdom of a sustainable approach to laboratory design. There are clear reasons for embarking on these projects, quantifiable benefits. There are financial reasons and other reasons for an organization to make these design choices. The leaders of a university can be persuaded and motivated by this data. They can directly receive the benefits of decisions based around them. They can be influenced by this data. This has certainly been the case for me as an administrator. But I also have a role as an academic. In my capacity as Director of Graduate Studies, one of my charges is to focus and support our students with respect to their research and learning endeavors. So research and learning. In this role, I often find myself switching perspectives and imagining what a particular issue looks like from the point of view of a student, a graduate student, a postdoc, an undergraduate student who works in our laboratories. What does a student gain by working in an efficient academic laboratory? What happens when we populate our new platinum and green coated labs with students? Let's look at the question from two perspectives that I mentioned previously, from research and from learning. So with respect to research, will the student's science work better or worse in a more efficient laboratory? Will she achieve more publications working in a newer lab than she would have over the old lab that she worked in? Will her dissertation get completed any sooner? So from personal observations, I can confirm that great science can be done in really awful laboratories. That picture of a cluttered, old, inefficient lab space that I showed you previously resulted in a Nobel Prize for the professor who supervised students in that space. An old and inefficient minus 80-degree freezer can keep biological samples just as cold as a modern ultra-cold freezer. Those old constant volume fume hoods can keep a researcher safe just as a new and frugal variable air volume fume hood can. So we've demonstrated that good science can be done in old laboratories. We've also observed that great science can be done in new, modern, and efficient laboratories. We've demonstrated that there are great benefits to the university, to the environment, for building these laboratories in a sustainable manner. But we still haven't struck upon a direct benefit to students for working in those laboratories. What happens to them? So let's focus on the learning piece of the puzzle, that other part of my job that I often focus on. Some of our faculty may say that we have a captive audience with respect to our students. They work in our labs, and they work in our labs a lot. They're there during the day, they're there in the evenings, they're there on the weekends, they're there on the weekdays, they're there on non-holidays, and they're there on holidays too. So they're present in our labs. They come from all over the world, and during their time here and afterwards, they'll be embarking on careers that take them across the country and back around the world. I believe we have an opportunity to share knowledge and values and even condition behavior for the betterment of our students and our society. But we have to be proactive in our educational efforts in order to realize any of these benefits. If we as administrators or facilities managers or environmental health and safety professionals or as educators do not involve or engage our students or researchers on the issues of sustainability and efficiency, they're not going to gain anything by working in these labs. So how do we reach our students so that we can effectively impart this knowledge and these values to them? How can we condition their behavior to a degree that we desire? How do we make sure they're empowered to bring these things with them as they embark on their own careers after they depart us? In the brief time we have together this morning, I'd like to share with you 3 areas in which we're looking at this and we're trying to address this challenge. So we found that our students are very competitive, and they're only a little bit less competitive than our faculty. And we've tried to leverage this competition in a very positive manner. So if our researchers lower the fume hood sashes on their fume hoods, they can conserve a lot of energy, and they can reduce the emissions that our university puts out by a lot. So we engage with our researchers to try to enable them to do this. Because of the nature of the research we do, and because of the things we have going in and out of fume hoods, and because of the number of fume hoods we haven't done an en masse deployment of automatic fume hood closers. So we rely on conditioning their behavior and educating them. So we have educational outreach. We have magnets that we stick right on their fume hoods that say, save energy, be safe, shut the sash. We have other mechanisms by which we educate them. We partner with our vendor. Mott manufactures the fume hoods we use. We have them imprint right on the stainless steel clasps that we have on our fume hoods, shut the sash. So they're reinforced multiple ways to do this. We provide our researchers with instantaneous real-time monitoring of the exhaust levels in our laboratories. So at the entrance to each laboratory, we have a digital display that tells our researchers what the exhaust rate in their laboratory is in cubic feet per minute. We also provide parameters for them. So if you were to open every single fume hood sash in that lab, the exhaust rate would be 24,000 CFM. If you were to close every single one of them, it would be 7,000 CFM. So when a researcher walks out to go to lunch, or when they leave at the end of the night and they're the last one out, if that number is anywhere north of 7,000, they know something's wrong, and they should stop and go back and lower their fume hood sash. We provide goals for our researchers. So each lab has an average CFM exhaust rate that they try to meet every month. And we run a competition. We quantitatively track this information. We share it with our researchers and faculty and staff, and reward good behavior. So labs that meet their own goals get rewarded with a fantastic party. Wine, cheese, olives, crackers. It's a lot of fun, and it's inclusive. It's not one group against another. It's not one group winning to the detriment of another. Everyone can win if they meet their goals. We don't always tell them, or it's not always apparent, that we keep moving the goalpost for them. So the goals over time have gotten more stringent and harder for them. But we've had a lot of great success with this, and people pay a lot of attention to it. They don't want to miss out on the parties. The faculty don't want to get one-upped by the professor down the hall from them. While we have them all together and they're socializing with each other and enjoying the food and refreshments, we have displays and presentations that are introducing them to other topics of sustainability and efficiency. So it's an outreach program as well. Based on the baseline data we collected before we started these competitions, and because we've ruled it out in so many fume hoods in our department, we estimate now that we're saving over $240,000 per year because of changed behavior in our laboratories. Another area where we've been focused on is on equipment purchasing. So we've observed that often students are the key decision makers with respect to obtaining scientific laboratory equipment. And they're often making those decisions based on technical merit of the equipment and price. These pieces of equipment are getting charged to faculty grants, and oftentimes faculty listen to their students or charge them with making these purchasing decisions. So how do we insert sustainability or efficiency into the equation when they're making these evaluations? So we've come at it from a couple different ways. First, we try to make our students aware of these issues. We try to educate them. We have demonstrations. We invite vendors to come directly into the labs or into the department, bring their equipment with them, allow people to see them, touch them, listen to them, hear about them. We host parties, commissioning parties, for the first instance of an efficient piece of laboratory equipment to go into our complex. So just like you'd commission a boat when it was launched in the water and break a champagne bottle, we commission a new piece of equipment. And we have a party, and we have refreshments, and we allow people to look at them and ask questions and learn about them. And we've had a lot of success with that. We also have what I think is a really cool program with respect to student grant funding. So students themselves are able to author grant applications to a central fund, and it's run by our Office for Sustainability, to cover the difference in price between inefficient pieces of equipment and a more efficient model. So here we have students getting experience writing grants, learning about efficiency and sustainability, as well as demonstrating leadership to their PI, that they're making good technical decisions for what they bring into the lab, but also good financial decisions, because they're winning money for that professor to help offset costs in the lab. So we've been very pleased with that program, which is a relatively new one as well. And thirdly, a topic that we've just started thinking about and just started planning for, and that is expanding the sustainability education beyond efficiency and emissions. So over the last 10 years, I think Harvard's made a lot of progress with respect to energy efficiency and emissions, and we've educated a lot of people about these things. But we feel now it's time to start looking beyond those without neglecting them, and making that conversation more expansive. So we're interested in engaging with our students on topics like human health and well-being. What are the containers used to deliver food to our campus? Is it safe for those to be used? What about personal care products that people use in the dormitories or at home? Can we educate them about those things? Can they be making better decisions about those? Can we pressure our vendors to do a better job with that? We want to include the students in our dormitories and in our laboratories in those conversations. We want to focus on nature and the ecosystems around Harvard, the biodiversity in Harvard. Do we have different trees here? Is it important to have different trees? What about ground cover? Is it important to have more bees on campus? Wouldn't that be kind of cool to understand what you're seeing when you're walking through campus? These are all areas that we're just now starting to lay out a roadmap and a vision and a goal for at Harvard. And we want our students to be included in that from the very beginning. So our hope is we can bring all of the experience and knowledge we've gained over the last 10 years where we were focused on energy and efficiency into these new realms. And this was all done in an effort to educate and empower the workers and leaders of tomorrow, which our students will become. So as this 17th century Dutch painting entitled "An Alchemist's Experiment Takes Fire" nicely illustrates, there's a long history of things going very badly when we poorly educate our students. We collectively cannot afford to miss the opportunity of extending their education to issues of efficiency and sustainability. Thank you.